Hi lads, this video is going to go through the 2012 B-3 question. So it tells us 2012 marks the centenary of the sinking of the Titanic, the world's most famous ocean liner, which was built in Belfast. The image on the right shows the new Titanic signature building, which was opened in the city to commemorate the anniversary in April. The building incorporates planar faces which intersect as shown to represent the bow of the ill-fated ship. Figure B3 below shows the plan and elevation of a model of two such intersecting planes, ABCD and ABEF. The horizontal and vertical coordinates for the outer points of the two planes are also given. So you can see there, you have A, B, C, D, E and F, and from it you can gather that we're missing height H. So at some point we're going to figure that out. Part A then. Draw the given plan of the two intersecting planes and locate points A, B, D and F in elevation. Part B, determine the height H for points C and E and complete the elevation. Part C, determine the dihedral angle between the two planes. And then part D, determine and indicate the horizontal and vertical trace of the oblique plane that contains the surface A, B, E and F. So just to speed up the video, I have part A complete there, so I've drawn my plan and my elevation, and you can see there that for point C in plan, I don't know the height of it yet, so I just have a vertical line drawn there, and the exact same for point E, so it's just a straight line going up there for now. So that's all we can do in terms of part A. For part B then, we're told to determine the height H for points C and E. So in order to figure that out, what we want to do is take an edge view of plane, for example, ABCD. If we can take an edge view of that plane, basically seeing that plane as a line, like imagine having like a set square here, turn on its edge so we can see the whole surface as just a continuous line, we'll be able to then determine how tall C is. Because we already know the height of B, and we know that A and D are on the ground. So if we take an edge view looking in the direction here along AD, we want to see AD as a point. If we see AD as a point, it's going to show the plane as an edge view, and then will give us the height C naturally as a result. So I'm going to look along AD first. I can take up point C and point B. So I'm going to draw my X1, Y1, perpendicular to that there. And as always, we go two views back. So for A and D, they're both on the ground, so we go one view back, two views back, measuring to our elevation. So A and D are both on the ground. Therefore, when we're looking at A and D are on the ground there. We don't know the height of C, so we can't take any height for that yet, but we do have the height of B there. So we can take the height of B. There it is there. Follow it down and take it up. There's the height B. And we join AD to B there. We can see that it's now appearing as just a line, so an edge view. So once again, imagine the set square, turns on its edge, and now we've determined as a result is where C hits that line, we now have the height of C. So that height H that we were looking for initially, we can now take that and apply to our elevation, because we can work both ways. If the height, for example, B there is this height here, we can take the height of C here and mark it up here. We know the H is the same height for E as well. So we can take that height and mark it off for E there. And that's what's going to help us complete our elevation. So B connects to C there. C connects back to D. And then B to E is going to be hidden detail there. And E to F is hidden detail there. So that completes parts A and B. Next part, part C, determine the dihedral angle between the two planes. So we know from our previous questions, we first have to determine what's common between the two planes. So if we look at the question, we can see that A and B are common between the two. So there's our line of intersection. We can see, as always, that line is not parallel to the XY line in either view, so therefore we don't have a true length. So we're going to take an auxiliary out here to get our true length as a result. We take our x1, y1, perpendicular to that. And let's take that just around here. So there's our x1, y1, and now what I need to do is just take up the rest of my points then and then measure them off. So as always, we go 2 views back, 1 view, 2 views. So D, F and A, they're all on the ground. So I can mark D and F there, and A there. Point B, follow it down, follow it up. There's B, and then we have points E and C. So E and C are the same height. Follow C down, take it up, and E happens to be on the same line. So C and E are there. And we draw A to B first, and we can see now is that's our true length. A to B. So we can mark off TL to show the true length, that line of intersection. B connects to C then. And then C connects to D. And then obviously D will go back to A as a result there. And the other plane is just behind it then. After that then, what we need to do is, we need to take a second auxiliary in order to find the dihedral angle. So we need to look perpendicular to our line AB. Imagine like your pencil. That's a true length there to there. If we look in perpendicular, we're going to see it as a point view. That's what we want to see. We want to see a point view so we can see the true angle between the two planes. Make sure to keep this view nice and close as I'm running out of space just on the right hand side. So once again, we go 2 views back. 1 view back is into this auxiliary, 2 views back into my plan. So to keep the space close, so I don't go off the page, I'll create a measure line then touching off corner E, just to reduce the distance I'm taking on my compass, because I'm very tight to the side of the page. So point E is the first point I have there, and E is actually touching off it, so when I take E up and out, there's point E there. F is my next distance on this line. Follow it up, there's F there, follow it out. There's point F. Then D and C. Take my distance out to D there. Follow it up, follow it out. There's D. And then C is my last distance on this line here. follow C up and follow it out. And for C, I'll just move it over just a little bit. You can see it's just going off the page there. So there's points E, F, D and C, and what I've left to do is A and B. And you can see that the distance for A and B are the exact same, and that's what we want. We want to appear as a point view. So when we look along AB here, which shares the same line, that's going to be our distance out to AB there. And when we line it up, we can see now that ABEF all appear as a straight line. So we're creating like an edge view there. And then ABCD as well, they're appearing as a straight line there. Once again, an edge view. Imagine the two set squares together. Imagine they're sharing the same common line. You can see the true length looking in that way. When you look in perpendicular, you can see as a point view, and that's what's giving you the true angle in between there. And there's our dihedral angle. If you're told to indicate it, for example, just measure the angle in between the two. The last part then, it tells to determine and indicate the horizontal and vertical trace of the oblique plane that contain the surface ABEF. So we're looking at this plane here. So we know what our traces. Our traces are the lines that intersect with the ground, where it cuts through. Where it cuts through the horizontal plane, it cuts through the vertical plane. We know from this question that A and F are on the ground in elevation there. So therefore, that has to be part of the trace there. So what I can very simply do is go to A and F and extend it through. And that's where I'll have my horizontal trace. We know from previous questions, in order to find a point on the opposite trace, we go parallel to the trace in plan. So for example, I could take point E. So make sure I go parallel to it. E taken parallel. Then we take it straight up. And take E across to meet it. And there's a point on our vertical plane. Or sorry, our vertical trace. Join it back, because 2 points form a line. And there's where our vertical trace is there. And that then completes the question.